Augmented reality has widely been adopted in machine task tutoring systems due to the benefit of its spatial and contextual visualization. In AR tutoring systems, some tutoring elements have been proven effective and welcomed by end users. We categorize these elements into avatars, animated components and arrows, expectations, and subtask descriptions. To better organize these elements to deliver an efficient learning experience, we propose AdaptTutor, an adaptive AR tutorial system for machine tasks. AdaptTutor recognizes a learner's real-time states and adaptively feeds the 4 tutoring elements in 5 possible level of detail combinations. All 4 tutoring elements, animations, expectations, and subtask descriptions, expectations and subtask descriptions, only subtask descriptions, and no tutoring elements. We built a machine learning-based system to recognize a learner's state and the machine state in real time. Using this information as input, we developed an adaptation model that dynamically adjusts the level of detail according to the learner's real-time performance. We demonstrate the adaptive learning process using a laser cutting machine task. Note the tutorial was created by an expert through embodied authoring. First, the learner should open the machine lid. The current level of detail is 3. The system detects that the learner is stuck and increases the level of detail to 4 so that an additional animated component appears. Now the system detects a correct operation and adjusts the level of detail to 3 for this step and all other similar operations. The next operation is picking up the cardboard. The system recognizes that the learner is not paying attention to the target and increases the level of detail from 4 to 5 to bring out the AR avatar. Following the avatar, the learner finds the cardboard and picks it up. The next step is to put the cardboard into the laser cutter. This is a similar operation as the previous step. The system then decreases the level of detail to hide the avatar. AdaptTutor is also able to detect a learner's interaction state. If the learner spends too much time on an interaction, the level of detail will be increased accordingly. In this step, the learner correctly closes the lid so the level of detail is further decreased from 3 to 2 for future similar operations. In addition, AdaptTutor can detect a learner's mistakes and increase the level of detail. As the learner repeats the tutorial, AdaptTutor gradually decreases the level of detail according to their performance. At level 2 and 1, no step-by-step hint is provided, so the learner is encouraged to recall and perform the task by themselves. Here, when they forget to adjust the laser head and try to close the lid directly, the system increases the level of detail to inform them. In the end, with the help of AdaptTutor, the learner masters the task without any tutorial. To evaluate the performance of the adaptation model, we conducted a 2-session remote user study in VR. 24 users learned 2 machine tasks using AdaptTutor and a non-adaptive system as the control group. The non-adaptive tutorial was equivalent to the 5th level of detail in the adaptive one. The users first learned the tasks following the tutorials and then did a test without the help of tutorials. We analyzed the test completion time and the number of mistakes. The results show the adaptive tutorial leads to a better learning outcome. Meanwhile, the preference vote also shows that AdaptTutor is more welcome due to the adaptive and personalized learning experience. Please refer to our paper for more details. We propose AdaptTutor, an AR adaptive tutorial system for machine tasks.